In this video, we're going to learn how to solve side-side-side triangles using the law of cosines. Now, I wrote the law of cosines in the top left corner for easy reference. And now we're on to the last congruent triangle case. The last one that has a unique triangle given three sides. So in order to solve these, I'm first going to label everything I need to. So this triangle will be triangle A, B, C. And I know side A is 4, side B is 3, and side C is 6. Now in order to find an angle, I'm going to need to pick an angle to start with. I'm going to be focusing on this cosine part. So if I were to take this equation and solve for cosine, what I can get is another formula, which could be subtract a squared and b squared and divide by negative 2a, and I'll get cosine of c is equal to c squared minus a squared plus b squared all over negative 2ab. So this is another way to get more directly to your answer. So in this case, if I wanted to know what angle C is, I know that cosine of C, by rearranging this formula up here, is equal to c squared minus a squared and minus b squared. I forgot to put the other minus. Let's subtract both of them. It's all over negative 2ab. And now I can plug in all those values that I have. So cosine of c, this angle would be equal to c squared, which would be 6 squared, minus a squared, which is 4 squared, minus 3 squared, all over negative 2 times 4 times 3. So cosine of c would equal 36 minus 16 minus 9, all over negative 8 times 3, so negative 24. Cosine of c will equal, this is 25 subtracted from 36, 11 over negative 24. And then c would equal the cosine inverse of that value. Now, this is a negative number going inside the inverse function, which means I'll probably get an angle that's bigger than 90 degrees. Which makes sense for being across from the biggest side. So cosine inverse of negative 11 over 24 gives me c is equal to, is approximately 117.28 degrees. So yeah, being across from the biggest side, that makes sense. 117.28 degrees. Now let's find another angle, which I can do in a very similar fashion. So if I wanted to find, let's say, the cosine of angle B, which would be the smallest side, smallest angle, cosine of b would be equal to b squared, it's the match, minus a squared minus c squared, the other two sides, all over negative 2ac. So cosine of b would be equal to b squared, so that's 3 squared, minus 4 squared minus 6 squared, all over negative 2 times 4 times 6. So cosine of b, when you enter all of that, gives you the fraction 43 over 48. You'll get a double negative, making it positive. So b would be equal to cosine inverse of 43 over 48, which makes b approximately cosine inverse of 43 divided by 48, 26.38 degrees. And in case you don't believe me on the fraction there, if I did 9 minus 16 minus 36, you get negative 43 over negative 2 times 4 times 6, negative 48. And you get 26.38 degrees. And if I wanted to find angle A, it's the last remaining angle. It should be between those two, since that side length is between the other two side lengths. So I would just subtract those two angles from 180 degrees. So we have 180 minus 26.38 minus 117.28 is equal to 36.34 degrees. Now for the next example, I'll label my triangle again A, B, C. And I know side length A, which is 9, side length B, which is 7, and side length C, which is 10. And now let's say you don't remember to put it into this form. You can still work it from the original law of cosines. So if I was looking for, let's say, angle A first this time, then I use the law of cosines. A squared is equal to B squared plus C squared minus 2BC cosine of A. And again, I'm looking for angle A, but I'll plug in all the information that I know, which will be 9 squared is equal to 7 squared plus 10 squared minus 2 times 7 times 10 cosine of A. I'll simplify, so 81 is equal to 49 plus 100 minus 2 times 7 times 10, which would be 140 cosine of A, giving me 81 is equal to 149 minus 140 cosine of A. Now I just want to solve for A. So I'm going to subtract 149 from 81. Negative 68 is equal to negative 140 cosine of A, divide by negative 140. It gives me a decimal here, but if I want to make it into a fraction using the calculator, if you hit the math button and hit the first option, enter, you can change it right back into a fraction. So you would get 17 over 35 is equal to cosine of A, which you could have gotten if you moved it over to the left side and divided both of those numbers by 4. So now A is equal to the cosine inverse of 17 over 35. So A equals cosine inverse of 17 over 35, 60.94 degrees. And again, I could do the same thing. Let's say I want to go find angle C next. That should be the biggest angle. So I should get something bigger than 60 degrees since it's the biggest side. And if I didn't remember how to rewrite it this way, again, I could just go it from its original form up there. So C squared is equal to A squared plus B squared minus 2AB cosine of C. C is 10 squared is equal to 9 squared plus 7 squared minus 2 times 9 times 7 cosine of C. So 100 is equal to 81 plus 49 minus 2 times 9 times 7. That one's a little harder to do in my head, so I'm just going to type it in. 126. 126 cosine of C. (81 plus 49 is 130, so I have 100 is equal to 130 minus 126 C, cosine of C. Subtract 130, I get negative 30 is equal to negative 126 cosine of C. Then you have 30 over 126 is equal to cosine of C, which divide the top and the bottom by 2. I can get 15 over 63. And then they're both divisible by 3 as well, so I can get 5 over 21 for its final form. So now I define angle C. I can just take the cosine inverse of that fraction, 5 over 21, and C will equal the value 76.23 degrees. And if I want to find the final angle, it should be smaller than both of them. I can add them together and subtract it from 180 degrees to get angle B. So 180 minus 60.94 minus 76.23. B should be 42.83 degrees. So I'm going to write these in. And again, this is how you can solve these triangles when you're given all of the sides and no angles. And if you have been wondering why we don't have to check for more than one case when we use the cosine inverse, because cosine inverse's output is 0 to 180, so it would find the correct angle no matter what, while sine inverses was negative 90 to 90 degrees. And you would only really use the positive angles, so the extra negative 90 to 0 would never be used, and there could be another possible solution in the second quadrant with sine inverse. While cosine inverse, all of its outputs can give me anything from 0 to 180, which is what I really want to work with when I'm dealing with triangles. And that is how you solve side-side-side triangles using the law of cosines.